welcome to this short presentation. My name is Dennis, and I'll walk you through the schematic design of the Arduino Mega. Yeah. So before we start, this is how the Arduino Mega looks like. See the pins layouts, the connectors, and the passive components. And as you can see here, this is the main heart of the Arduino. We'll look for all these schematic components and work that out. So without wasting much time, let's open our design software. All right. So for this project, we'll be using the schematic software, that is the KiCad. The KiCad is an open source software that is used for schematic design, PCB, and also the 3D modeling of various projects. Yeah. And the assignment that we're given, we're supposed to work on the schematic design, move on to the PCB design and the 3D modeling. But with this presentation, I am going to focus on the schematic design, and since that is the foundation of all projects, I'll walk you through. So first, when you download and install the KiCad from the official website, it looks exactly like this. Okay, yeah. So before you can do any other thing, you need to first create a project, and by doing so, you go to File, create a new project, and you choose defaults. You double click the folder count for you to create, and then you do that. I've already created one at the background, so I don't need to waste much time. After creating, you can see that it has automatically created a schematic file and then that's of the PCB file. But our main interest here is the schematic design. So quickly open the schematic editor and let's start. So when you open it, this is how the schematic editor looks like. It has so many logos around, and our main focus is to learn how to place components and connect them with ease. So place components when it comes to KiCad, and I recommend you have an external mouse, be it wireless or cord. This helps you move around freely, unlike using the touchpad of your laptop. Yes, so with a mouse, you'll be able to zoom with ease as well as span your page anyhow you want it. So for you to place your component, there are two ways. You either use the shortcut, which is by pressing A on a keyboard and then the cursor changes to something else, or you either go to your far right and then look for the place symbol logo, which is like an amplifier, the triangle shape. You click on it and then the symbol dialog box opens. You see it here. So now when you get this, you either select the component that you want to use and place it, or you search for it on the search bar. So like I mentioned earlier, Arduino Mega has two components which are very, very important. And the very first one is the heart of it. That is the Mega 2560. So we'll search for Mega. It's a microcontroller anyway. We search for Mega. Mega 2560. Yes, that is it. We pick the first one. But notice this. Anytime you are placing a component, try as much as possible to get the one with a footprint so that when you are moving on to the PCB designs, it becomes easy. So I'll be picking this one. I'll place it, and also we'll also need the other component, which is the Mega 16U. Yes, you can see Mega 16U2. Yes, I have it here. I've already selected it, so it's here. Yeah, you double click and then you place it. Unfortunately, it looks like our space has already been covered, but do not worry. Let's work around the space. And to increase your working space, you would have to come to the page setting. So look at where my mouse cursor is. You click and it opens the page setting for you. Since we are only interested in changing the size of our workspace, we only go to the size and then select the wider scale, and then also we leave the orientation as it is. You click. Now our working space has increased. Now there are other passive components that we need to also add them. That is the resistors, the capacitors, and also the USB ports and other vital components. And for you to place them, you still use the same method I taught. That is using the place symbol, you search for them, resistor, all of it. If you're able to get them, you place them quietly. And how do I connect any component to the other? For instance, let me pick a resistor here. Let's say I have this resistor. I'll place it here. Now, how do I connect it? you zoom in, and in terms of connecting them, it's very simple. You pick your mouse pointer to the terminals of all the components like this, and then it changes to the green line, which represents the wire. So if you should press on that terminal and then you move, you can see that it has drawn a line. You click to change directions and click, and then you click. That is how you draw your lines, or that is how you connect the components. If you find that challenging, the other way of drawing or connecting your components is by pressing W. So you send your mouse cursor to where you want to draw the wire to and press W, and then you move, just like how you did the first one. You are good to go. Simple as that. So that is how you connect components together. Yeah, so without wasting much time, I've already done the finished work of how the schematic diagram of the Arduino Mega 2560 looks like. And here, yes, with time and dedication, you should be able to build something like this, and it's interesting. So as you can see, I have various connectors here and all these passive components, which are very, very, very important when it comes to building schematic diagrams. Now, the next very important thing that we need to do is to run the ERC, or the electrical root check. Now, what this does is that it will help us catch errors or unconnected cables or components with ease before moving on to the next stage. Now, let me demonstrate for you. First, for you to locate the ERC, or the electrical root checker, you would first come to inspect, and then you click on electrical root check, and you click on run. It will scan through all the components to identify errors and violations. So as you can see, we have so many errors being faced here. A couple of them are the loose ends of the connectors. Now, how do you work on this? If you have connectors that are not connecting to anything, you easily have to place the no flag, the connector flags on it, so that the system identifies it as a no connected space. So if you should place the components and without connecting them to anything, other components, you need to add the no connect flags, so that if you run the ERC connectors, it doesn't flag you errors like this. Done the finished work of how the schematic diagram of the Arduino Mega 2560 looks like. And here, yes, with time and dedication, you should be able to build something like this, and it's interesting. So as you can see, I have various connectors, components, which are very, very, very important when it comes to building schematic diagrams. Now, the next very important thing that we need to do is to run the ERC, or the electrical root check, errors or unconnected cables or components with ease before moving on to the next stage. Now let me demonstrate for you. The electrical root checker. You would first come to inspect, and then you click on electrical root check, and you click violation. So as you can see, it is testing all the runs. See, we have so many errors being faced here. A couple of them are the loose ends of the connectors. Now, how do you work on this? If you have connectors that are not connecting to anything, you easily have to place the no flag, the connector flags on it, so that the system identifies it as a no connected space. So if you should place the components and without connecting them to anything, other components, you need to add the no connect flags, so that if you run the ERC connectors, it doesn't flag you errors like this. So I'm going to close all of this, mark it as connectors for you to see. It's very simple. Sorry. So I'll do this and then run the ERC again for you to see how it works. And the interesting part about the ERC is that it helps you build correct and professional schematic design. So as you can see, this is just a wire that is just being drawn. We'll also get rid of it very soon. So just to demonstrate to you how the ARC works when it comes to schematic. All right, so let me run it again for you to see. So initially our errors were 152. After connecting those no connect flags, let's see. It has now reduced drastically to 61, and we still have more errors to correct. Is that right? So basically, this is how I was able to build the ARC, the schematic diagram of the Arduino Mega 526. Yeah, with a whole lot of dedication and time, you should be able to build it, and it's very, very, very interesting. Yeah. Yes. So for complete beginners, when you're starting, it looks complex, but you must learn how to build small components bit by bit to get to this stage. Yeah. I want to reduce this errors to 0. Yeah, let's run the ERC again to see. Good. It has now dropped to 23 and more to go. So, hello everyone. Once again, my name is Dennis, and this is how I was able to build a schematic design of the Arduino 2560.